Welcome to Spaceverse, your portal to cosmic adventures. When sun-like stars reach the end of their lives, they don't go quietly. Instead, they leave behind cosmic masterpieces, brilliant, glowing shells of gas and dust that expand into space like a final, breathtaking farewell. These are known as planetary nebulas. And one of the most mesmerizing examples recently captured by the James Webb Space Telescope is NGC 6072, a celestial splash of paint found deep within the constellation Scorpius, the Scorpion. What we are looking at in this image is the dying breath of a star not too different from our own sun, a star that has exhausted the fuel keeping it alive for billions of years. As that nuclear fire flickers out, the star sheds its outer layers into space, creating a nebula of luminous gas. What's left behind at the center is a tiny, incredibly hot core called a white dwarf, essentially the exposed heart of the former star, glowing faintly in the twilight of its life. But what makes NGC 6072 truly fascinating isn't just its beauty, it's its complexity. The James Webb Space Telescope, or JWST, has provided two extraordinary images of this dying system, one taken in near-infrared light and another in mid-infrared wavelengths. Together, these views peel back the layers of the nebula, revealing a structure far more intricate than astronomers ever expected. Located about 3,060 light-years away, as measured by the Gaia mission, NGC 6072 has always intrigued scientists. Previous data hinted that it might not be a simple, single-star nebula. Instead, Gaia's observations suggested the presence of two stars at its heart, a binary system. Now, thanks to JWST's detailed imaging, that suspicion has gained strong support. The evidence is written into the very shape of the nebula itself. Some tens of thousands of years ago, the story of NGC 6072's transformation began. Inside one of the stars, the nuclear furnace powering it began to falter. As the fusion reactions in the star's core dwindled, the outward pressure holding the star up started to collapse. The outer layers began to sink inward, only to heat up and reignite fusion in a last desperate attempt at survival. That temporary surge of energy caused the outer layers to violently eject into space, forming the nebula we see today. What remained, its stripped, incandescent core, became a white dwarf. This process is a stellar death with artistry. Most planetary nebulas tend to take on familiar shapes, some appear round and smooth, others form twin lobes or hourglass-like structures. But NGC 6072 defies these categories. It doesn't look neatly symmetrical or uniform. Instead, it's chaotic, like a cosmic splash of paint thrown across the night sky. In JWST's near-infrared camera view, astronomers noticed something remarkable. Multiple pairs of outflows streaming from the dying star in different directions. One pair extends from about the 11 o'clock to 5 o'clock position, another from 1 o'clock to 7 o'clock, and possibly a third that runs vertically from 12 o'clock to 6 o'clock. It's as if the nebula is being sculpted by invisible hands, pushing and twisting its material in all directions. The likely culprit, the companion star. When two stars orbit closely, their gravitational tug-of-war can distort how gas and dust are ejected. Imagine two dancers locked in a spin, flinging ribbons of color around them. The shifting directions of these outflows are believed to be a result of these gravitational interactions, complex, dynamic, and stunningly beautiful. The JWST's use of false colors, representing infrared wavelengths that our eyes can't see, helps scientists decode what's happening within the nebula. The dark orange regions show clumps of gas and dust, remnants of the star's former outer layers. These clumps are dense, possibly protected from harsh ultraviolet radiation by thick veils of dust. Meanwhile, the glowing blue areas mark regions that are relatively dust-free, where ultraviolet light from the white dwarf is ionizing the surrounding gas, causing it to glow. By this point in its life, the central star has already shed up to 80% of its mass. What we see is not just light and color, it's the record of destruction and rebirth, the physical remains of a once stable star now spread across space. But the near-infrared image is only half the story. When we move to the JWST's mid-infrared instrument, another extraordinary feature emerges. A series of concentric rings expanding outward from the nebula's center. These rings may hold the key to the system's mysterious dual nature. One explanation is that they're carved by the companion star. As it orbits the dying star, it may slice through the expanding gas, creating repeating gaps that ripple outward over time, like the rings that form when a pebble drops into water. Each ring would represent a moment in that orbital dance, a signature of the second star's invisible influence. But there's another, equally intriguing possibility. These rings could be the result of pulsations within the dying star itself, episodes of instability that cause it to periodically puff out more gas every few thousand years. Each pulse leaves behind a new shell, a glowing time capsule of stellar evolution. MRI's ability to capture longer wavelengths of light is what makes these faint details visible. Infrared light can penetrate dust that would otherwise block our view, allowing astronomers to peer straight into the nebula's core. There, at the heart of NGC 6072, JWST reveals a tiny pinkish-white dot, the central star system itself. But even with JWST's unmatched clarity, the two stars remain indistinguishable. If the companion exists, it's orbiting so close to the dying star that the telescope can't resolve them as separate points of light. Instead, they blend together, a cosmic secret still hidden behind layers of dust and time. No matter which explanation turns out to be true, the images from JWST highlight something profoundly poetic. The death of a star is not a quiet fading, but a dynamic and creative process. The gas and dust expelled during this stage will one day drift through the galaxy, enriching interstellar space with heavy elements, carbon, nitrogen, oxygen, that will go on to form new stars, new planets, and perhaps even the building blocks of life itself. NGC 6072, in all its vibrant complexity, is a preview of our own sun's distant future. In about 5 billion years, our star will begin its own transformation, expanding into a red giant, consuming the inner planets, including Mercury and Venus, and maybe even brushing the edges of Earth's orbit. Then, when its nuclear fuel is fully spent, it will shed its outer layers, creating a glowing nebula not so different from NGC 6072. At its core, a white dwarf, the sun's remnant, will remain, cooling slowly for billions of years more. It's both humbling and awe-inspiring to realize that the James Webb Space Telescope isn't just showing us the death of another star, it's showing us our sun's eventual destiny. The universe is, in many ways, a cycle of creation and destruction. Stars die so that others may be born. Their ashes seed the next generation of worlds, carrying within them the raw ingredients for new beginnings. Every nebula, every glowing cloud in the night sky is a story of change, of something ending so that something else can begin. The planetary nebula NGC 6072 reminds us that even in death, there is beauty. The chaos we see in its swirling patterns is not random. It's the language of cosmic transformation, a sign that the universe is constantly reshaping itself. And with telescopes like JWST, humanity now has front-row seats to witness it all. We can finally see the intricate details of how stars die, the delicate structures left behind, and the clues that reveal the hidden lives of binary systems. Each discovery brings us one step closer to understanding not just the stars in our galaxy, but our own place among them. So the next time you look up at the night sky, remember that somewhere far across the Milky Way, a star is performing its final act, casting its colors into the darkness, painting a nebula like NGC 6072. And one day, our sun will join that cosmic gallery, leaving behind its own masterpiece, a glowing testament to the cycle of life and death written in the stars. The universe is full of stories like this, where endings give rise to new beginnings, and even in the quiet death of a star, beauty shines brighter than ever. If you enjoyed diving into this cosmic wonder, make sure to like, subscribe, and join us here on Spaceverse, where every week we explore the mysteries that shape our universe, one discovery at a time. Until next time, keep looking up because the next great story might already be unfolding in the stars above.